Back for more vector data model. Last time I talked about selection and query. Remember, you can select things interactively using the eye tool or one of many geometries to just go into ArcMap and select things interactively. You can also select by attributes using structured query language. You can select by location depending upon either spatial relationships of one set of features or how they relate to another set of features. A query is a request to a database. In a query, you return a subset generally of the original information that you have. It's going to be the same geometry, but a set of the features, not all of the features. So I'm going to talk about some other geoprocessing operations. One of the ones that you use most frequently in analysis is buffer. And what buffer does is it creates a polygon. So the output of a buffer is always going to be polygon, some distance from either a point, a line, or another polygon. So here I have an example of what's called a false color image. So false color means the red in this image is actually green vegetation. I have some features on here, some polygons that look like homes maybe, and I have points in the middle of those homes which might be the centroids of those homes, and I have lines which could maybe be a road feature. Okay. I can buffer the points, so I can say draw polygons at a distance from those points, and I'll end up with a set of circles, and you see that on the right. Okay, you might use this if you were saying maybe estimating impervious area and you knew that the average size of a home was so many square feet, but you only had point locations for the homes, so you could create these polygons to estimate the area of the footprint of the home. Okay, how does it work for lines? Okay, I have these road lines. I can buffer around the road. You see what that does? It creates polygons, again, always creates a polygon, a distance from the road. So you can see that this would be a single line segment or a single polyline, so it makes a single polygon. So the input set of lines looks to me like it was 1, 2, 3, 4, 5 different lines, so you get 5 polygons in the output. Buffer around the polygon. Let's look at those home footprints. We draw the buffer around the polygon, and you can see it creates new polygons around each home at a certain distance from the outside edge of the polygon. Okay, there's a thing called dissolving that you can use in buffers. So in this point buffer, you see that I have a circle for each point. I can dissolve or get rid of all of the overlapping pieces of circles and make the polygons into larger polygons, and that's what this would look like. So I've gone from 4 different circles here to one large polygon. That's dissolving. How does that look for lines? Again, I think it was 5 lines here. If I dissolve these common boundaries, I'll end up with one single polygon. Same story on buffers for polygons. A bunch of different polygon buffers, dissolve the common boundaries, it goes down to one polygon buffer. So you can tell it to dissolve or not to dissolve when you run the buffer. There's a lot of options for buffering. When you practice this in lab, you'll be able to do these things and you get a feel for what the options are. So if I'm buffering points, I can say make the distance the same for every point, or if I have a certain field inside of my point feature class that has a number in it, I can make the buffer the size of whatever that number is for each point. So let's say you had points that were 10, 20, 30 for this number. You could get buffers that were 10, 20, 30 feet or meters or whatever that is. Okay? You can tell it to dissolve none of them, just make all polygons for each input feature. You can dissolve all of the polygons, or you can dissolve it based upon a list of common fields. So if polygons have a common value for a certain field, you'll go ahead and dissolve it. If they don't have a common value for the field, you won't dissolve it. What are the options for lines? Same as for points. You can make the buffer size different depending upon a field value if you have that in there. You can actually buffer lines to the left or to the right or to both sides. And at the end, you can make your buffers round corners or be flat at the ends. Dissolve is the same, none, all, or list. Okay, overlay. What an overlay is about is it's merging coordinate or geometric information and usually attribute data from two separate vector layers, and it creates a new layer. It creates new geometry that has different geometry generally from either one of the input layers. And in most cases it combines the attributes from those input layers. So this is really powerful. You can use overlay to do a lot of different things. I'll go through quite a few of the common operations in overlay for the rest of this video. Okay, there's uncommon types. Point in point. Let's say I have one feature class that has all the cities in the world. I have another feature class that has just the capital cities. If I overlay those two, I can get information from all the cities in the world only as it applies to the capital cities. Point in line. Example here is highway accidents. If I have traffic accidents that are represented as points that occur on a highway which is represented as a line, I can find out which point or which section of the highway had that traffic accident. Line in line, you could use intersecting roads. When you intersect lines with lines, you'll get lines that are common. The more common types of overlays are point and polygon, line and polygon, polygon and polygon. So notice those are all overlays where one of the inputs is a polygon feature class. Clip is a real common one, and you can think of clip as basically just taking a piece of your input layer and only retaining information from that piece. So let's say I have a big large area in my map, but I have a study area that's smaller. I'm only interested in the study area. I can do a clip overlay that'll take the big area, clip out the piece that I'm interested in, and give me only the results from that piece. So this is called the input layer, this would be the clip layer, and this is the output layer. Notice that the output layer has two different features geometrically, but both features are different from these input features. Notice also that the attributes, in this case it's 1 and 2, whatever the attributes are of the clip layer, they're not retained in the output. So the output extent is the same as the clip layer. Attributes are not combined, so it doesn't care what the attributes are. It's only going to take the attributes from your input and put them in the output. Okay, here's another one, common one, intersect. This is the common area between two features. You're used to these Venn diagrams, so this is an intersection of two polygons. You'll get a result of this single polygon, and it will contain attributes from both the input and the overlay feature class. That's intersection. This is union. That's like OR. So in this case, I'll end up with 3 polygons. I'll end up with one polygon that looks like that, another one that looks like that, and a third one that looks like that. Okay, this polygon will have only the attributes of A, this will have attributes of A and B, and this will have attributes of only B. Here's an example of point and polygon intersect. So I have points, I have polygons. I'm going to pull out the common geometry between these two. Input layer, overlay layer, output layer. What happens with all of these overlays, your output layer is of the lowest dimension of the input layers. So here I have a 0 dimension, points are 0 dimension. I have a 2-dimension polygon, and so my output is going to be points. Imagine an example where I have cities, I have counties. I'm going to get an output of cities, but the cities will have not only the city attribute information, they'll also have the county attribute information. So you can see these orange ones will get the attributes from this county, the green ones will get the attributes from this county. And again, the output's the lowest dimension. Okay, common geometry, common extent, and combining attributes. Not everything from the input is going to make it to the output because the extent of this overlay layer is less than the extent of the input layer. Here's a line and polygon. You can imagine maybe, well, let's see, I have an input, I have an intersect or overlay layer. I get an output that instead of a single line is 2 lines. One of the lines has attributes from A, the other has attributes from B. They both have attributes from 1, and these 2 line segments in sum are shorter than the input line segment. You can imagine this being streams and a land use overlay. I'm going to get sections of the stream according to what the land use is where the stream is flowing. So instead of having one line, I'm going to get two lines, and each line segment is going to have a different land use attribute value. Again, lowest dimension, lines are lower than polygons, so you're going to get lines out. Here's polygon and polygon. Same kind of approach. We have an input layer, we have an overlay layer, and we have an output layer. We're going to get attributes from both the overlay and the input layer in the output. Intersect is only going to give me common geometry between the two. So this geometry is common to the inside of this geometry. That's what my output is. You can imagine an example where we have soil types over here, we have crops growing in here. I end up with crops by soil type in my output, and the extent of my output is only the extent of my crop layer. Union. Union's going to give us both. It's OR, right? So I'm going to get the extent of A plus the extent of B, and I'm going to get the attributes from both. So over here I only have attributes from one. In the middle I'm going to have attributes from 1, A and B, 2A and B, 2. Symmetrical difference, you can think of that as the opposite of intersection. So intersection is going to give you geometry that's common to both. Symmetrical difference is going to give you geometry that's not common to both. So in this case, this area here is common to both, so that's the only area that you're not going to get in your output. Identity. Here we have an input layer and an overlay layer. We get an output whose extent is that of the input layer, combines attributes from both the input and the overlay layer. So I'm not going to get this piece of the overlay layer in my output. I'm only going to get the extent of the input layer. Clip I showed you before. Here's an example of clip. Input, the clip layer. The output has the extent of only the clip layer because it's clipping out just that piece, but it doesn't put any of the attributes from the clip layer into the output. You only get the same attributes that you had going in. Erase. Erase is kind of like the same as maybe the opposite of clip, but you can imagine it as an eraser. So just taking an eraser to your input layer, and the shape of the eraser is the shape of your erase layer. So I'm basically going to take this geometry out of my input layer, and the result will look like this. Split. What split does is it takes your input layer and it divides it into multiple layers or multiple feature classes depending upon the definition of your zone layer, okay, your overlay layer. So in this case I'm taking a single feature class that has two features. I'm going to split it into two different feature classes. Each one will have two features. So you can imagine if I had the United States and I had zones that were all of the states, I could produce individual feature classes for each state by overlaying individual states on the conterminous United States. Multiple layers out. Update. This one isn't in your book. The way update works is it's kind of like paste. And so I have an input layer here. I have an update layer. What update does is it takes your update layer and it pastes it over the top of your input layer. So in this case, the geometry that's in here in the input layer is lost in the output layer because the update pasted right over the top. And so your new geometry doesn't include this line that came down here before, and those features aren't there. Each one of these operations is accessed through what's called our toolbox, and in your labs you'll have a lot of experience working with this stuff and getting used to this. One of the things you might do is spend some time looking at those graphics and understanding the concept of how the overlay techniques work, and also kind of trying to remember the terminology of some of these words, because even if you don't remember exactly how to get to something, if you can remember the word that applies, you can go to the help system. The help system will have graphics that'll show you how an overlay works and have an explanation of how the overlay works. So remember the names of the different operations and try to remember the concepts graphically of what's happening when these things are done. Remember the basic thing that determines the difference between queries and overlays are query returns a subset of existing geometry, and an overlay in general is going to give you new geometry, new shapes, new features. Okay, next time I'll talk a little bit about geoprocessing workflow. That's chaining these things, these overlay operations and these queries and selection techniques together into a series of steps that can accomplish a larger goal. And also the scope of the operations. There are 3 levels of scope. I'll talk about that in the next video.